Good morning, dear students. Today I am going to take some problems in Cauchy's integral formula. First one, compute integral over c dz by z minus 3, where c is the unit circle mod z minus 2 equal to 5. See the diagram. Circle with center and radius. So from the diagram, z naught equal to 0 and z naught equal to 3 lie inside the curve C. Hence by Cauchy's integral formula, f of z naught equal to 1 by 2 pi I integral over C f of z dz divided by z minus z naught. You are familiar with this formula. Here, what is your f of z? 1. F of z naught is f of 3, that is equal to 1 because f of z is a constant 1, independent of z. So no need to substitute 3. And hence 1 by 2 pi I integral over c dz by z minus 3 equal to f of z naught equal to f of 3 equal to 1. And hence the value of the integral over c dz by z minus 3 equal to 1 into 2 pi I, that is equal to 2 pi I. Hence 2 pi I is the value of the given integral. Another sum, integral over c cos z dz by z into z square plus 8. Evaluate the value of this integral. Let f of z equal to cos z divided by z square plus 8. Now if you equate the denominator to 0, you will get z square plus 8 equal to 0. Therefore, z square equal to minus 8. In other words, z equal to plus or minus root of minus 8, that is plus or minus 4 into 2. So, if we take the square root, 2 root 2. It lies outside C, hence f of z is not analytic at the point, whereas z equal to 0 lies inside C, and therefore f of z is analytic at z equal to 0. See, look at the denominator z into z square plus 8, and therefore by equating to 0 you will get z equal to 0 or z square plus 8 equal to 0. That gives z equal to plus or minus I2 root 2, both lie outside, and therefore the only point which lie inside C is z equal to 0. You all know Cauchy's integral formula. F of z naught equal to 1 by 2 pi I integral over C f of z dz divided by z minus z naught, and therefore 1 by 2 pi I integral over C cos z dz divided by z into z square plus 8 is f of z naught, that is f of 0, that is equal to cos 0 divided by z square plus 8, 0 square plus 8, that means cos 0 is 1, therefore 1 by 8, and therefore 1 by 2 pi I integral over C cos z dz equal to 1 by 8. In other words, if you cross multiply 2 pi I, you will get pi I by 4. So pi I by 4 is the value of the given integral. So these two sums are the applications of Cauchy's integral formula. Next we will see some more sums related to the formula for higher derivative. You know the formula for higher derivative. F power n of z equal to factorial n by 2 pi I into integral over c f of zeta d zeta divided by zeta minus z the whole power n plus 1. Now we will see the first problem. Evaluate integral over c sin z divided by z minus pi by 2 the whole square, where C is the circle mod z equal to 2. Here, take f of z as sin z. Look at the denominator. Z minus pi by 2 the whole square equal to 0 implies z equal to pi by 2. Now, z equal to pi by 2 lies inside the circle mod z equal to 2. And therefore, what is f dash of z? Sin z if you differentiate cos z. What is f dash of z naught pi by 2? Cos 90, that is equal to 0. By the formula for higher derivative, f power nth derivative of z equal to factorial n by 2 pi I into integral over c f of zeta d zeta by zeta minus z power n plus 1. And here, what is your n? 1. And z equal to pi by 2. Therefore, f dash of pi by 2, f power n of z, f power 1 of pi by 2. In other words, f dash of pi by 2 equal to factorial n, factorial 1 divided by 2 pi I into integral over c. What is your f of z? Sin z dz divided by z minus pi by 2 power n plus 1. So, 1 plus 1. In other words, 1 by 2 pi I integral over c sin z dz by z minus pi by 2 the whole square. Left hand side value we all know 0, and therefore if you cross multiply 2 pi I to the other side, you will get integral over c sin z dz by z minus pi by 2 the whole square equal to 0 into 2 pi I equal to 0, and therefore 0 is the value of the given integral. Now, compute another problem. Integral over z cube dz by 2z plus I the whole cube. Yes? 2z plus I the whole cube in the denominator. If you take 2 outside, it will become 2 cube, and that is 8. So, 1 by 8 into integral over c z cube dz by z plus I by 2 the whole cube. Now, z plus I by 2 equal to 0 implies z equal to minus I by 2, which lies inside the circle mod z equal to 1. And therefore, here n equal to 2 and z equal to minus I by 2, f of z equal to z cube by 8, f dash of z equal to 3z squared by 8, f double dash of z equal to 6z by 8, in other words 3z by 4. Write the formula then. And therefore, f double dash of minus I by 2 equal to, yes, 3 into minus I by 2 divided by 4, that is equal to minus 3i by 8. In other words, minus 3i by 8 equal to, you will get 1 by 2 pi I integral over c z cube dz divided by 2z plus I the whole cube. And therefore, the integral over c z cube dz by 2z plus I the whole cube equal to minus 3i by 8 into pi I, that is 3 pi by 8. Yes, I think you are able to follow. One more sum. Compute integral over tangent dz by z minus pi by 4 the whole square, where c is the circle, unit circle, mod z equal to 1. Here, z not equal to pi by 4 lies inside the circle mod z equal to 1. And let f of z equal to tangent. F dash of z equal to secant square z. And therefore, f dash of pi by 4 equal to secant squared pi by 4, that is 1 by cos squared pi by 4, that is 1 by cos 45 the whole square. Cos 45 the whole square is 1 by root 2 the square. So, 1 by root 2 square, you will get root 2 square, that is nothing but 2. You know the formula for higher derivative is f power n of z equal to n factorial by 2 pi I into integral over c f of zeta d zeta by zeta minus z power n plus 1. And therefore, f dash of pi by 4 equal to factorial 1 by 2 pi I into integral over c tan z dz by z minus pi by 4 the whole power 1 plus 1. And hence, 2 equal to 1 by 2 pi I into integral. If you cross multiply 2 pi I, you will get integral over c tan z dz by z minus pi by 2 the whole square is nothing but 4 pi I. 4 pi I. That's all. Thank you, ma.